Firstly, we've got the brake caliper fitted, the bracket for the throttle, and then we fabricated a battery box. And in this episode we finish off installing the brakes. We then move on to some of the electronics, including the isolator, installing the speed control unit, and then finishing off by installing the batteries. Welcome to episode 11. Okay, so now we need to turn our attention to the brake system. So the first thing we need to do is to cut this outer sleeve to the right length. So this will go into this housing, then it goes up here onto a clip like that. So that will hold that in place, and then down at the other end it will go into the brake housing over here. And on this piece you've got this adjustable screw. So that moves the outer sleeve in and out a little bit. That gives you some fine tuning on the absolute brake position. So I'll set that roughly in the middle, so it gives us adjustment in or out. So we need to get this outer, take the inner cable out and then cut the outer to the right length. So I'm just going to put these loosely in position. I'll do that properly in a minute, but I just don't want to bind these up too tight. I just want to make sure that I've got the right kind of travel or the right distance set. Now to trim these to length, I'm going to use these Knipex cutters. These are really good and really hardened and perfect for doing this. There's still some effort involved in actually crunching through the cable, but these should do the job. Okay, so it should be about there. Double check. Measure twice, cut once. Alright, let's go for it. So now I need to feed the inner cable through, so I'll feed it obviously this end first, and that'll be the retaining part on the other end. Right, before we set this cable to the final length, we'll make it a little bit easier. I've got this 2mm twist drill, so we'll just put that in there. So that's moved us off the hard stop here, and then we can grip the calipers fully onto the disc and then set it like that, and then when I take this off that should relieve the pressure a bit. So basically that will be no brakes, and somewhere there will be full brakes, somewhere between those two. So we're kind of simulating the pedal being in the fully brake on position, if you like. Okay, so this is the bit now where we're going to squeeze this lever here so we've got full brake pressure. Remember, we've set the brake pedal at the other end for about 2mm of travel. So let's see, what's that look like? Sorry, I know I'm blocking the camera. I can't really do this otherwise. That's pretty good right there, yeah. So the brake's almost on. Right, let's take that little key, the twist drill out the other end and see how the brakes feel. Okay, so we take this out. Right, so this, what I'm about to do isn't a completely fair test because the balance bar here hasn't got the other one done yet, so it's just going to be pulling on that. The idea of this balance bar, by the way, is just to try and give equal forces here. So the majority of the tuning of getting everything set up should be done on the cable length and turning the threaded adjusters and so on. But when you're actually driving the car and actually using it for real, then this balance bar should hopefully balance these forces out, give you that last bit of sort of automated brake balance. Right, so anyway, let's just try and see if that's going to give us what we want. So that's free. And that's locked up. Free and locked. Yeah, so that travel doesn't seem too bad. It'll probably be a little less, so when we get the other one hooked up. And we can adjust it here so we can fine tune it. Right, so I'll do the other side because that's a bit more fiddly, and around there and I'll probably end up blocking the camera. And I just need to check that it's going to clear the sort of electronic control unit. It's going to be here, make sure that's all going to work. So I'll bring you back in a minute when we've done that one. Right, so I've got the second brake run installed. We'll keep these cables long for now, cut them off a little bit later, just in case we need to make any fine adjustments, or even if for some reason we need to thread them back through and make any minor adjustments around here. Okay, so now we're just going to connect this up here. Let's hold them out of the way. Okay, let's give it a try. Let's talk a little bit about the electronics. So for the speed control, I'm going to be using this one. This is off an electric bike, so it's made by Yeun Tech. It's a 24 volt unit, 500 watts. The 1 to 4 there, that refers to the voltage range for the throttle. So as you come up to 1 volt, then it will start turning. If you go above 4 volts, then you're already at maximum. And the range of other outputs down here. Now I've translated these and then labelled up the cable, so I'll just tell you what each one is. The large one there, that one's for the motor, so the 2 wires go to the DC motor. Then the battery ones here, I've made up this cable here with a fuse holder in it, and then these 2 go to the 12 volt batteries. I've also got the ignition switch. I won't be using that as such, so I'm going to basically wire that permanently on, because I'll be using one of these high voltage, well, high current kind of isolators in the battery feed circuit. So we just turn this on, and then the cart's ready to go, and then when you're done, you turn that off and the cart's immobilized. So that's what we'll do for that one. Also on here, the 3 wire one, that one's for the throttle, and I've wired it up accordingly. So there we are. Yeah, so I've already tested it out, and I know it needs between 0.8 volts and 4.3 for the minimum and maximum speeds. That's the actual voltage that I've measured between min and max. And then you just need to give it a power supply, so you've got 5 volts and 0 volts there on the black and red, and the signal goes down the blue. So we've done that one, done that one, done that one. Then this one, this is the brake lever switch. And now for what I'm doing, you wouldn't really need that, because when this switch is activated, what it does is, there we are, it sends power down to the brake light one, which will illuminate the rear brake. Now we're not going to have any brake lights on this. However, I will be using this in some form, because I believe it's a legal requirement in many countries that if you pull the brake, it needs to kill the throttle. So what I'll be doing is I'll be connecting this up via a little switch onto the brake pedal. So when you press the brake pedal, you'll see there's a hole there which I've drilled. That will be tapped out to have a kind of a plunger type switch. So when you press the brake, this will be activated, and if you've also got the throttle on, it will kill the throttle. A bit of a safety feature really. Then the other things we got on here are the charging ports. We can charge it up. And this last one, okay, we won't be using that, but that's indicators if we needed those. So that's an overview of the speed controller. So what we're going to talk about next is how we're going to supply the speed control signal from the throttle into these 3 cables. And the speed controller that came with it looked like this. So there's 3 functions on here. The first is you've got an ignition key. When you turn that, it just makes a contact between 2 of the connections. Very straightforward, really. The other thing it's got on here is a voltmeter, up to 24 volts for the battery supply. And then the last feature is the throttle. Now this came with obviously a much longer tube than that, and there was a grip over the top. And what I've basically been trying to do is to get inside, to get this mechanism here. It's kind of gone over center and clicked into place, and I can't get it off. I think I'm going to damage it. I've stripped this right down and tried to get inside and break this off and or pull it off, and not had any joy. I had a look on the internet. Some people say you can turn this to the full extent and then pull it out, but I've not been able to do that. So not really sure if I'm going to be able to use this. One of my thoughts was, a very crude way to do it would be to wind some cord around this and then connect that to the throttle. So when you pull the throttle like this, the cord that's wrapped around here kind of pulls like a drum. But I don't think that's going to look very nice. So I don't think I'm going to be able to use this in the end. I might be able to salvage the volts display, but in terms of throttle, I don't think we're going to be able to use that. So we need to understand what's going on in here. So inside here is a Hall effect sensor and then a magnet on here. And as that magnet moves past that Hall effect sensor, it creates a voltage signal on the green cable here that goes between the 1 to 4 volts, or more or less 0 to 5 volts, to the speed control, so it knows the throttle position. And the reason they use a Hall sensor with a magnet, it's non-contact, doesn't really wear out, much better than a potentiometer that can have dirt and sort of tracking errors on it over time and eventually probably need replacing. So that's why they do that, and they're relatively inexpensive. The thing is, I don't think I'm going to be able to get this out of here. So other options are, I managed to find this quite neat little device. So again, it's a Hall effect sensor. It's a throttle or thumb operated throttle. So you've got a groove there for it to move in. The clamp clamps it onto an existing handlebar, and you just press that down, and again it's moving the magnet past the sensor, and you've got your 3 wires. You've got your 5 volts, your 0, and then you've got the signal wire down the green. So that was quite nice, but I couldn't really see a nice way to package this and put it next to the existing throttle. I thought about having a little arm coming out and it would push onto it, but I couldn't really get it to fit. It looked a little bit awkward, so I don't think we're going to go for that. But just to let you know what's inside here anyway, it's not exactly like this, but this is an example of a Hall effect sensor. So that's your Hall effect sensor there, and when you bring a magnet near to this, it changes how the electricity flows through that. So I think it's got a PN device, so it's a semiconductor device, and it biases the current one side or the other, and it's able to detect that. And there's various adjustments you can make here. A little bit of signal conditioning there from the chip, and you just put plus and minus in here and you get an analog signal out. When it's like that with nothing connected, you get 2.5 volts out. When you bring the north end of a magnet near, it will go one way or the other. So let's say, for argument's sake, as you bring the north near, it goes from 2.5 down to 0 volts. If you turn that magnet over and bring the south end near, then it'll go from 2.5 up to 4.5. So clearly you need to provide a signal between 0 and 5, or at least 1 to 4. So I don't know exactly what's inside these, whether they've got 2 magnets, one a north and a south facing, and the north one goes past first and the south one goes past next, and it's able to then span the complete range. Or they may have a biasing magnet at the back like that. So when you do that, you can pull the voltage towards one end, say 0 volts, and then when the other one goes past, in theory you should be able to get that up to 4 volts. It all starting to sound a little bit complicated and a little bit too much effort to try and So implement this in a little housing. I did look at such an arrangement, so this would be on the throttle and it would move past like that, and that would give you the signal you needed. So in the end I went with something very simple. So this is a linear potentiometer, something you might find on like a studio mixer desk. So you'd have a kind of your button at the top here and it would slide it backwards and forwards like that. And the idea is you're just either using it as a voltage divider, or you could use it as a variable resistor, I guess. So with this one you've got your 0 volts and your 5 volts going across there, and then the green is reading off the position of this arm here. So at one end it will read best part of 5 volts, and then the other end basically 0 volts, and then every position in between is some scale between there. I believe these are linear, you can get logarithmic ones, but I think I went for a linear one for this. It was about £2, so not particularly expensive. This one's a 10k value. It probably wouldn't matter too much, but somewhere around 10's a pretty nice value to go with. And that gives you your signal out the green that you can send into the speed controller and vary the speed. And the way I'm going to do this is, so this is how I've designed the housing to take this, is that the throttle has a slot in it and it will pick up on this arm, and as you move the throttle like that, it moves this arm backwards and forwards like this. So now seems about the right time just to put the speed controller on here, just to make sure we've got enough room. I think we've cleared it around here. Okay, so we'll stow some of these out of the way that we're not going to use, and I think that's going to work quite nicely. It's plenty of clearance from everything. Looks okay. I know it shouldn't bother me, but it does bother me that that writing is now upside down, but I guess that's because we're just looking at it from this angle. Next bit's very fiddly, so I'm going to get this in here and get these tiny screws through to hold it in place. Right, wish me luck. Try again. Design this. Dropped on the floor. Where the hell did that go? So what I think I'm going to end up doing is making a little brass sort of a turned round bar with a slot in it. I glue it onto the potentiometer, and then it will be a loose fit in here or running fit in here, because at the moment it's just going to catch it either side, but that might be okay just for test purposes. So that's the potentiometer installed. The ignition, I'm just making up this little link lead that will just put it permanently on, because we're going to have this big battery isolator for doing the on-off. One ignition link lead. So that goes on here, ignition. So to make the battery isolator, I decided to go for the template method. So I marked something up out of cardboard and then made sure that was going to be a pretty good fit on the isolator switch. Then I found a scrap bit of stock, blued it up with the Sharpie, and then it was over onto the surface plate to scribe all the measurement lines in. So I marked the centres of the holes as well, the slot for the cutout, and then finally the profile around the outside. And then over to the CNC machine to machine it out. I decided to do it in kind of semi-automatic mode, so I was basically machining it, using it like a manual CNC machine, just with the DRO, and then just moving up to the lines. It was quite a large part and there was quite a lot of overhang, but I just took it nice and steady and crept up onto my marked lines, and then we soon had it cut out. Okay, now we've got the isolator in, we need to button everything else down. So I've just lifted the speed controller up on these washers so I can get this cable tie underneath there, and we'll just tie off. So we've got the indicator we're not using, the brake light, and the ignition that we've just wired on permanently because we're going to use the isolator. So we'll just tie those up out of the way. Next we'll get this brake line secured. Now the next one to do is the cable that goes to the motor. Next we'll wire up the isolator. So we've got the main power feed that goes into the speed controller. So put that one on the top. So our next job is to get this fuse holder down onto those M3 threads down there. And then the back of that fuse goes onto this cable here, which has come from the battery, and that goes on there. So a quick overview of where we're up to. So the motor cables are now tied down, the brake cable's tied down there. We've got these stowed up out of the way, these spare cables. The isolator's tightened down, got everything tightened up, everything connected, and the fuse holder we put in a few minutes ago, that's now connected as well. So now we're going to turn our attention to getting the batteries mounted in the battery box and get those wired up. On the last video there were quite a few comments about using these old style lead acid batteries. Yeah, totally get it. Yep, these are pretty ancient now really. The main reason I went for these were, so for a pair of these, the two 12-volt batteries is £25, which when you compare to the lithium batteries that you can get, they were around, well, last time I checked, around £150 to £200. And the problem is my daughter, she's pretty young, she might play with this for 10 minutes and get bored and move on to something else. I just don't know. If she really takes to it, and you know we're fed up of waiting for it to charge up, or we want longer run times, whatever, then yeah, we'll go and put some lithium in. They're pretty slim, they'll easily fit in here, it's an easy upgrade. But just at the moment I think these are dead cheap, they drop in, and you know they're definitely going to work. They're what was used in mobility scooters, so they're no problem. I did some calculations on these, probably get 15 minutes run time, maybe 20 minutes, depends how she drives it. We'll just see how we go really. Yeah, so I'm all up for upgrading to lithium, but these are dead cheap, so we're going with these just for now. So as you can see, I've just put this self-adhesive foam on here. It's about 4 or 5 millimeters thick. It comes on a roll like that. I've had it for quite a few years. I bought it off eBay just for another job, and thought it would be ideal for this. It just gives them a little bit of protection. That's one. And two. So I've got the harness threaded through this bracket up here, and now it will go onto these battery terminals. These are 12 volts each, so we'll run them in series to make 24 in total, and they're 7 amp hours, so we'll get 7 amp hours capacity. And then there's a little link lead that goes between them. Just double triple check it and I've got this right, I don't want it to go bang. Yeah, that's right. Actually that one felt a bit loose, I'm just going to nip it up a little bit. Not sure if you're supposed to do it like this, but I'd rather it didn't come undone, or arc, or just cause some random intermittent problems that you can't track. So, oh yeah, that's better. Let's do that one again as well. Okay, so that looks okay. Now we just need something to secure the batteries in place, stop them shooting out. I've got lots of this Velcro, which is really handy. It's like you can thread it through itself and tighten something up, and that really is very tight and it's quick to undo. So I think we're going to do that and put that through here. I've got one on the other side. that tight. I think you feel pretty good. So you're not going to come out in a hurry. Right, looks okay. Now I need to feed the inner cable through. I've managed to feed it through there, but not feed it through there.